Hello everyone, this is Rohan Meshram and welcome back to my channel Scribbles in Bioinformatics. In this second video on using the software NAMD Automator, here I will demonstrate how is that you create the input files for NAMD Automator. For using NAMD Automator, the pre-solvated system is required whose charges are already neutralized. So the system that we are using in this case is the complex of enzyme trehalase in complex with its substrate trehalose from Mycobacterium tuberculosis. The parameters for trehalose were obtained from Swiss Param server. Here we will start by creating a PDB-PSF pair of a protein ligand system using the PSF gen script. So let me show you what are the input files that are required. First, we will require the protein. This particular PDB ID or this particular PDB file is the protein that do not contain any ligand, and hence we have called it as apoform of the protein. All the resulting files obtained from parameterization from Swiss Param server are present in this tar.gz file. This is the file that you usually obtain when you use Swiss Param for parameterization. So what we need to do now is to unzip this archive, and you might locate in this MMFF folder the pre-required coordinate and the topology file of the ligand molecule. This is what we will need later on. Therefore, I am simply copying it and pasting it in our working directory. So, basically this file contains the topology of trehalose, and top all 27 protein Na will contain the topology for all the amino acid residue and water molecules that are present in our system. So based on this background, let us start VMD, and we would be using VMD to create the initial PDB PSF pair. For creating the PDB PSF pair, we need to use this TK console button, and from this TK console we need to change the working directory first, and working directory can be changed by using this simple cd commands. And now I will paste the path of my working directory so that we can reach all the files would be accessible to us. If I give this dir command, all the files that are required are present over here. Now all we have to do is to load the PDB file. You can use this browse button. You can simply load it. Once you have loaded the PDB file of the protein, you can browse and load the PDB file from the PDB file of the ligand molecule. Simply load it. All you have to do is to open up the TK console. You have got a file called as standard.pgn, and this standard.pgn file contains all the necessary commands that are required for creating the initial PDB-PSF pair of your trihalase in complex with substrate trihalose. You can visualize, or you can check out this content of this PGN file later on, but over here I will show you how is that you use this script. All you have to do is to source the script standard.pgn and hit enter. And with this, my friends, you have already created the complex.pdb and complex.psf as a initial file that is required. Let us visualize it. You can simply open this PSF file first, then load the coordinate data of the respective PDB PSF pair like this, and here you go. You have got this PDB PSF pair of your protein and ligand. The next step will be to solvate this protein ligand complex in a water box. To do that, my friend, all you have to do is to again open the TK console, and the command for solvating are already provided over here. All you have to do is to just copy and paste those commands. This is the command that will import the package called as solvate. Next, we would use the utility of this solvate command to solvate our protein ligand complex. It will take complex.psf and complex.pdb as an input, and it will create a slab of 5 Armstrong, and it will create an output file called as complex underscore wb, which stand for water box, that will contain the solvated protein in water system as such. All you have to do is to hit enter and just wait till the solvation gets completed. So once this is over, you can simply exit. Now you can see that these two files of solvated system are generated. You can simply open it. I have opened the PSF file. You can load the coordinate of the water box, and I have loaded. As now you can see, the protein has been now completely solvated. Now the next thing that you need to do is to neutralize its charges, and to neutralize the charges of your system, you can do it using this extension menu. There is modeling, and then you can use this add ions utility in VMD. So once you are in this auto ionize window, all you have to do is to hit this auto ionize button, and my friends, ionize.pdb and ionize.psf files are generated, and this will correspond to your charge neutralized solvated system. Here you go. I am just showing you how the charge neutralized system looks like. Okay, fine. So once you get this thing, this is one of the input that is required for running the simulation. Now what we need to do is that we need to obtain the values for setting up the periodic boundary condition, setting up the particle mesh evolved, and we also need the values for coordinate of cell origin. And as I have already mentioned, we have developed a script called as PBC PME calculator that you can obtain from the place where you have already installed your NAMD Automator. So by default I have installed NAMD Automator in program files at x86. There should be a folder named NAMD Automator if you have installed it properly. Then there is this script called as PBC PME calculator. You can simply copy this script into your working directory, and you can use the content of this script for calculating PME grid size, for calculating, you can say, PME grid size and center of box and everything, right? So let me show you how is that you use this script. All you have to do is to again go to TK console. Make sure that you have already loaded the PDB PSF pair of the charge neutralized system, and once you are in the right directory, you can make sure that the PBC PME calculator script is already there in the working directory. Now all you have to do is to source this script called as PBC PME calculator, and just like that, my friend, it will create a file called as PBC PME grid size.txt, and this text file will contain your PME grid size, your cell basis vectors that will be needed for populating in NAMD Automator, as well as cell origin. So in order to successfully execute NAMD Automator, you would need all of these values along with the charge neutralized solvated system for your protein ligand complex as such. So this is it, my friend. This is the pre-required files that will be needed for setting up and running a molecular simulation using NAMD Automator. In our next video, we will demonstrate as to how do you use all of these files and set up an AMD simulation. That's it, my friend. Take care.